All right, we're back with more content, more coding content, but we're not going to continue the DSPy series today. Instead, let's continue the project cleanup that we started last time. So last time we sort of transitioned this project. And let me pull up our favorite block diagram drawing software. Let's see, what did we do? Here we go. So we had this older project, was kind of using system Python and the old requirements text way of dependencies, and there was a bunch of loose py files. So we sort of switched that over to UV, right? So now we had UV installed. No more requirements by project, UV log file, proper modules, organized in SRC folder. We didn't do the formatting though. What I'd like to do today is, and let me move a bit here. If we look at what we did, we kind of didn't really address the loose file problem, first of all, right? So let me switch here. Because, okay, sure, we have a proper Python module called score-based channels, but it's a single module with 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever, 15 files. This kind of screams like it should have submodules. For example, maybe a train submodule, a test submodule, an auxiliary submodule. There's also a plot code here, which looks like lives in the wrong place. Yeah, so let's work a bit on the files, right? Because we want these to be a bit more idiomatically organized. The other thing I noticed, so let's try to represent that somehow, right? Because, and I'm gonna go file level, right? So what we have right now in this project is we have a file called train score.py. Then we have another file called train ldamp.py. Then we have another file called testscore.py. And of course, the thing that defines our module is we have an init.py. Now, we would like to move this to submodules, right? So we'd like to not just have 13 files, but maybe like, let's say 3 submodules, right? And they would each have an init.py file. And they would maybe, for example, we want a train submodule, which has the train score, train ldamp, and something else. Okay, so this would be one module. Then we'd have another module, which has, maybe it has test score.py, test ldamp.py, etc., etc. A good question in idiomatic Python projects is, what do we do with files that seem like they don't belong anywhere? Those are fine if they stay. So okay, so maybe we have a third module which contains let's call it, what was it, auxiliary models. Also, actually, here's another mistake. These are gonna live inside a folder called train, right? So the script doesn't have to be called score.py. It just has to be called train underscore score. It just has to be called score.py. So then we get the really nice command line way of calling that, which is gonna be uv run -m. The first module name is a bit too long, but it'll be train.score, right? And as opposed to today's train underscore score. And I know it seems like such a minor change. Like, are we doing all this thing just to replace an underscore with a dot? Well, the answer is yes. It's for better maintainability and more idiomatic project structure. Right, so going back here, so this will not be called train underscore ldamp.py. It also helps now users to see because, oh, look, there's a train, and now there's a test module, and I can find matching files now, right? Instead of having to look for train underscore score and test underscore score, which are hard to detect quickly, now I keep them in folders called train and test, and the submodules are just named by the method. Same for the auxiliary one, right? If this is called auxiliary, we don't really need to call, we're just gonna call it models.py. And I believe there's a base models.py or something. And a bunch of other auxiliary stuff. This should be enough. The other thing we need to do is that there's also an NCSN v2 folder here, which is not a proper Git submodule, but it's a copied folder. We'll see. If we have time, this should be a proper Git submodule, which links to the original repo. So yeah, we'd like to move from this today to something like this, so better organized files. The other thing we need to do is everything in here should run. The reason why I say that is because last time I know we tried all the 3 training scripts and we had to fix one of them. But then we did, but actually I was looking a bit and we missed some tests. So we broke some test code, some of the code in the test submodule, right? So that would have to be fixed. We want to make sure everything works. What else do we want to do? Oh, of course, and then we like to run UVX ruff format, which is going to be a separate branch. It's going to be a gigantic PR, but 0 functional changes, right? Yeah, so ideally we'd like to, let's see if we can draw an arc here. Cartoonist. We cannot draw an arc here. Oh, we cannot. Oh, we can. Oh, something like this. And how do I rotate this? Well, this is not going to work. So we want to run UVX ruff format on everything, right? On this guy, we want to run it on this guy, and we want to run it on this guy. I'm just making its way through here. Okay, so then we're gonna have to run UVX format. This is gonna be a gigantic PR, but it will not change anything functionally. And actually, I guess the better way to represent this today is that we have everything in a single, right? So this is mono repo. That's a common name, I think. And let's see, train, what was this? ldamp.py. And we also forgot the dependency, I realized. So yeah, we're gonna have to make all the test scripts run. That should be it though. Once we make everything, the test scripts run, it should be everything. There we go. So today we want to move from this mono repo style to, or let's call it mono module, right? We want to move from this singular module to a more modular structure, and the changes to the README should be minimal. Yeah, this looks pretty clean. So let's do it then. So what I did is I forked the repo, because apparently I talked to 2 different people, and yes, that is proper GitHub etiquette. Even though these are public repos, you're not really supposed to work in public, which is, I don't know if I agree with that, but whatever, fully. Now, of course we're using UV, and because I forked the repo, this is a fresh repo, I lost the UV environment. Oh no. Well, we don't care now, because I can just do UV sync, and that's it. Everything is installed. On Windows. Remember, we're on Windows. And let's start with the folder changes right now. Yeah, let's start directly with the changes. So we want a train folder, and we want a test folder. That's it for now. Okay, so what would we want to do? Well, we're just gonna cut, paste. Well, that was pretty easy. So now we moved the 3. Of course we have to rename these. All right. Score, nwgan. Okay, so now we have 3 trains. The syntax has changed a bit. It's not from dot loaders anymore. Of course, I forgot something. To make this a proper module, it needs to have a init.py file. Okay, so this is a proper submodule now. So now, let's take a look at the imports a bit. Well, there's already a problem here because this is not from the same folder, aux models, right? But we can use the full submodule path now to, there we go, to resolve this import, right? So from score-based channels, from score-based channels dot loaders. Okay, and we fixed this one. Let's aim for a score from score underscore base channels. Now, it's not really, we can't change the project name. Let's leave it like this for now. It is gonna result in long commands, but that's fine. Okay, and from score based channels dot loaders. Okay, so then we fix these. Same thing for the test. We need a underscore init.py. Now there's a lot more tests. So we just cut, paste. And here are some of the, okay. So let's work nicely, okay? Let me see. So let's work truly isolated. So first and foremost, we forgot to add this sigpy dependency, which ruins some of the tests. Okay, so then we're gonna check out the branch. Add sigpy true depths. And I am on my fork now. Okay, so this will branch off of main. Now, how do we add sigpy? Well, we can just do uv add sigpy. I'm curious what version. Now, because we forgot to do this, we're gonna have to consult our old repo and see what version we used to use. I'm gonna get this out of the way. Can I? I can. So let's go to the commits. Let's see something before, like here, for example, right? Well, no, actually, the problem is the requirements text file is missing, right? So let's just go to the Modern packaging, here we go. This is what we deleted. What SIGPy did we used to use? 0126. For now, just for backwards compatibility, let's just use exactly this one, right? We don't want to mess with any functional stuff. So we just say SIGPy 0, what was it? 0126. I'm curious if UV knows how to, okay, it found it. Okay, so SIGPy dragged with it a few other dependencies. Nothing too drastic. It's compatible with the torch, and that's it. So UV lock, git status. So now we change both the lock and the py project file. Okay, so we just add these, and we say git commit, add SIGPy dependency, and we can push this to our branch now. Add SIGPy to deps on my fork. Now, okay. So now, given that we fixed this, this is an independent fix from our modular file structure. So let's check out another branch. Submodules. Off of main too. Now, if we do this, we won't be able to test some code that uses SIGPy, but it's only one script. That's fine. We always have the branch. We can go back and test that code separately. So let's check out this branch from main. Okay, and now this is where we can go back now. So let's go back. So we had the test submodule. Do we need to fix anything here? Yes, we need to fix anything here. Forgot to fix this last time for good. So it's from score-based channels.loaders. This one we fixed, but now it's from score-based channels.models and .loaders. ML we forgot to fix last time. .loaders. MMSC we also forgot to fix. Oh, which is pretty important. It's good we caught this. Now to test these, I think we need a model, but that's fine. We can just quickly train a, or actually we can, there's a command to download a pre-trained model from score-based channels. Import GAN, and from score-based channels, import channels. Okay, we have all the test scripts. What else do we need here? Definitely need an auxiliary. Models, which uses basic models, unit, basic models using loaders. And these are two experimental, these are two, okay, so we definitely need an auxiliary module. I have not seen this one. The name aux is not valid as a file or is this a Windows thing? Wow. What? The name aux is not valid as a file folder name? Oh, interesting. This is a Windows thing. I've never... Okay, so we cannot call this aux... Well... I'm curious what happens if a user tries to download a GitHub repo with an aux folder in it. I've never had to deal with this on Windows. Interesting. So we can't do this. So how are we going to call the... Let's revisit our drawing then. How are we going to call the module? Utils. It's not really utils, right? Utils is more convenience code. If this one has a bunch of neural networks in it, it's not really fair to call it utils. I'm tempted to call it models. except there's a loaders here, which is a PyTorch data loader. Let's see what Gemini has to say about this. I'm actually curious. What is an idiomatic name for a Python submodule containing PyTorch modules and data loaders in separate files? Models, networks, data sets, data, and okay, we're not going to do a data submodule for one file. Oh, engine is a good one, or components. Core. It doesn't include training loops. No, so it's not engine. It's either components or models. In many research and production models, acts the umbrella term. It contains data logic is to support the model. I think let's go with models because this is research code. Yeah, we don't want to be too hyper production focused. Models is fine. Okay, and we need a init.py file. And 1, 2, 3, 4, 5. Okay, another thing I forgot is that the test scripts are no longer start with test, right? So it's just L1 lifted. Aha, we changed the thing. We're gonna have to revisit everything, but it's fine. LDAMP, ML, MMSC, score, W again. Okay, so now because we change, and now these will be, let's call this DC GAN, just so it's, what did I do? Oh, DC GAN. Unrolled. I'm gonna give these more idiomatic names too, because I'm not too happy with these names. Unit loaders. Basic models is fine. These are still kind of a mess because these are actually only used, unit is self-contained, but unrolled uses stuff from basic models, right? Yeah. Oh no, it uses stuff from unit too, interesting. Oh, I know what's happening here. NCSN v2 has its own model that's used in the score. Yeah, okay, so these are actually, this unit uses stuff from basic DC GAN, okay. There's an unused NZ here because the discriminator doesn't care about it, that's fine. Okay, now we have to fix imports again, so let's see. This is fine. This is fine. Let's not clean up yet. This is fine. This is fine. This is not fine. It is from score-based channels dot models. Okay, and from score-based channels dot models dot unit. Okay. fixed finally. Now the test code has changed drastically because it's no longer loaders, it's models.loaders. Fine. Yeah, everything here needs some models. And also it's not called auxiliary models, it's called unrolled. Okay. Loaders is just models loaders. We're gonna reformat this, don't worry. It looks really ugly so far, but that's gonna be fine. Models again models. From score-based channels dot models import dcgan. We don't need as dcgan, so we save a bit of things here, which means we got the name right there. Train ldamp from score-based dot models dot unrolled and models loaders. Okay, score models loaders, and from score-based channels dot models import dcgan. Okay, everything is good. Now we just have interestingly, these files should live on the outside, I think, because these are application files. They're not module files, or let's call them library files, right? So I have this module, this big module called score-based channels, which is basically a library of libraries which handles training, testing, and result saving. But then this code, yeah, so we want this to be UV run plot. Yep, this seems right. Yep, this is called the UV script, not the UV module. So let's take these guys. And yes, I'm pretty convinced they should live. Okay, so now what do we have here? Score-based channels dot models dot loaders fixed. And the plot is fine, just matplotlib. Okay, so this is the big cleanup. Which branch am I on? Submodules. Yeah, let's do it. So git add. So git remove src everything.py. Except init, which we need to git restore staged. This one, we want this back. Status, and we want to restore. So unstage and restore. Okay. So we removed all the files. We moved 2 of them, and now we just need to add src score-based channels models everything .py, train everything.py, and test everything.py. And the net result should be a bunch of moves and renames. Yep. And the new files. Better submodule organization and fixed imports. And I don't have this branch upstream, so I'll create it on my repo. All right, we're done here. Very close to running the big UVX ruff format, which is gonna be hilarious. There's gonna be so many changes. Nothing functional, just drastic reformatting, and code is gonna look a lot better. Before we do that though, we have to test everything, right? Because we did so UV sync. Aha, I don't have SigPy. I should not have done that UV sync. That was a mistake. Let's test everything without SigPy, and then on that branch we'll test the SigPy. It's only one script that has it. So just for completeness, right? What we can do is there's a fancy way to do this. I mean, this is all the power of UV, because we can check out from this. What was the branch called? Add SigPy to depths. So we can check out the UV lock file from that branch and lock to it. Let's, we have to remember to, let's leave it. We'll test this later. Okay, so now I need the data, which I believe I did something with that last time. How did we get the data last time? Do we have CURL here? We do have CURL. Or did we do some... There's the data in the model we need to download. Do we just download these by hand, or what do we do? So make dir. So we have to make dir data. And we have to make dir -p. I don't know if -p is a thing on Windows. We'll learn that it is a thing on Windows. Okay, so that's good. So we made the data and the models folder. Okay, which should not be confused with SRC models, of course, because we know Python. Now we have to download the files there. I wonder if this works. CURL. I don't think it... No, it doesn't. So what the heck did we do last time? Did we just download these? I can't remember. Very confusing. How do we get that data in? Oh, we did, right? I think I'm starting to remember now. Okay, so we take this. This other one too, which is the smaller file. Okay, so this auto triggers download, that's good. And we need the model too, this PT file. We can close Gemini. I think the PT file is big. Nah, it's not big. Okay. So then we just need to put these in the right places. So we're gonna put, let's see. I'm just gonna do this off, where is it, score, in data. So that's magically there. Okay, so data is here. And then we can take the model score CDLC. Okay. This is all nice and good. Now let's test the train. Let's run the training code to see if it works. We're gonna have to change the readme a bit, but it's fine. So now it's uv run -m score underscore base channels dot train dot score, and that's it. It's probably working. There's a SigPy missing import, which we don't really care about. Yeah, it's working. I like to see where does it save things. Well, where does it say model score? Ah, it's gonna override my model, right? Yeah, CDLC. Which is fine. Like, actually, we don't care about that, right? How often does this thing save? Did it save? Oh no, I think it saves pretty rarely, right? Torch.save. Oh, it's just final. What is log path? Yeah, it's just the final model. Yeah, we're not gonna do this then. It's fine. Let me. Okay, so let's see. What other, did we do? Have anything else? No, we don't have any other fixes. I want to see where it saves, though. I am curious. So we'll do it this way then. Well, let's just train for one epoch. Oh, here it is. N epochs, just one. This should be fast enough, like 1 minute or something. Because I just need to convince myself that the path is right, although I'm like 80% sure it is already. I think we have 10,000 training channels times 32, so it should be around 300 steps per epoch. Yeah, that sounds about right. Okay, we're already up to 100. Is the loss going down? It must go down. These guys will work for sure, because before they were exactly here. Now, of course, they won't actually work, because, in fact, to be honest, like, yeah, these folders don't even exist. I doubt. The tune one does work. The plot, I remember these values, but okay, there we go. Did we save in models? Yeah, we did in final model. Okay, good, perfect. So everything works as expected for this training script. So now train LDAMP. Does this one save periodically? Torch.save. Nah, it's still the final one for this local directory. Models LDAMP. Okay, so we'll just give this guy an epoch 2 then. Fine. There we go. Oh, I think this one has some trickery because it's one model per SNR level, if I remember. So this script actually produces many models. I want this because I want the test to work too, but it will work. Yeah, this is not the issue. Batch size 128, 10,000, should be about 30. No. 100 or 80, right? Steps per batch. Yeah, it keeps going down. Train SNR minus 10 dB, and MSE is already below the SNR, so the model is doing something pretty good. Pretty good. Yeah, let's see, and where is it saved? Models, LDMP, flip, tune, blah, blah. Okay, good. So everything is exactly where it should be. Okay, I'm gonna keep this model, because, okay. Then wgan. We can do the same thing here. And iter. So how often is this saved? Save models periodic. Oh, it's also saved in the first epoch. Config and iter. Okay, so then we'll just do one epoch then. Okay. And again, just train wgan. And we're done for good with the training script then. Oh yeah, this is there's a lot more stuff to do though. Now this, oh okay, here it is. I see it already. wgan cdld. Interesting. Maybe we should have this save in. Okay, let's not change it for now, but this should definitely also save into models. All right. Yeah. It doesn't have progress though. It doesn't have a progress bar. Okay, there we go. Why no save? Oh, because I do epoch plus 1 500. Okay, I have to set this to 1 then to save every epoch. Oh, because we don't want to save the model at initialization, I guess, which is not the best choice. Yeah. Well, it kind of is, but yeah. Okay. Okay, there it is. Okay, so this works too. Perfect. Oh, I'm really itching to save this into models. Like, seriously? Yeah, it should definitely be there. Like, come on. This is just bad. Yeah. The directory should definitely be models. And let's run it again now. Oh, there's even a pre-trained model that's uploaded to GitHub, but that's fine. Oh, there it is. Okay, good. So it's up. It's gonna be up. Okay, now remember, because we changed this functionally, we'll do the interactive ad just for fun. These other guys want to restore. My point was we have to change the test to where does this guy find the model? Oh, here it is. Target directory should be models. That's it. Of course, hard-coded numbers here. Like this is, all this has to be changed, but it's fine for now. It's not hard. Okay, good. So now let's do the interact. What do we want to keep out of these? Well, we want to keep one change. So first we can restore src score train ldmp. We can also restore score. We want to keep one change, so we can add interactive src score train wgan. We're gonna do a patch s. Okay. No, we don't want to stage this one. Yes, we do want to stage this one. No, we don't want to stage this one. Quit. That's it. So now we just added one change, and we also want to add the test. So let's see what's left. Score based channels, train, wgan. Yeah, we don't want these guys. So then we can do a restore. And we want the test code, right? Yes. Git add source score based channels test wgan. Okay, and this will be called better wgan save load paths. Now technically this should be another PR, but we're not gonna go that crazy. Okay, so we finished testing all the train code, which we kind of worked from last time. Now let's test the test code. Let me just fire it up. UV run -m score based channels dot test LDMP. It should work now, you would think. Because, okay, so the SNR range, we want it to be just -10, okay? Because we only trained the model for -10. If we had let it, yeah, train longer, it would have. And the spacing should be 0.6. Where's the spacing? 0.6. This should work now. Data is there. Okay. Test. LDMP 146. Config. Oh, we're pretty much done. What is config? What? Oh, it didn't do anything? Why? Because my range is from -10 to -15? Sorry, to -5. Duh, because range is going reverse. So I wasn't actually testing on any SNR, so data was empty, config was empty. Now we should test on -10 and should save the results, everything should run. Yes, good, that's it. And there's even the results, LDMP, good. Okay, so we don't want this change because we just did this to test, so git restore. Oh, sorry. Damn it, I missed it now. Score-based channels, what was it? Test LDMP, we're done. Next one. We can't test this one, we don't have SigPy. ML. I think this one... Oh, I wonder if multi-threading works on Windows though. Good question. Works on Windows. Very... Aha, we may need the threading trick here. Okay, so let's see. UV run -m. Score-based channels dot test ML. We may find a bug here. I'm very confused. Why does ML want a model? Because it's just seeking something to... Okay, so we'll do the trick now. Let's take the model that's on GitHub. Because yeah, this code doesn't work. This code has never worked then. Nobody complained about it in public, so I guess it's not that popular. But we can actually load a model that's on GitHub because we have this score deepest, and I believe this one should have a config inside it. Let's breakpoint and see. But this is a change that we want then. This is a functional change that we want. It's unrelated to the refactoring, but it's fine. Contents.keys. Okay, there is a config. Good. Good. So we can, whatever we uploaded, at least this will work now, right? It's definitely a plus. Let's see. Test ML. Okay, it's trying to test on CDLD data. Ah, okay, we should change the default to C. Now this one doesn't have to be... Well, I guess if we give the example commands with CDLC, this should also be CDLC by default. I'm very curious about the multi-threading though on Windows. If Torch multi-thread, you would think PyTorch multi-threaded on Windows should work. Yeah, there we go. It does work. Okay. Okay, and it results ML baseline. Good. So we want these changes. All right, we want the CDLC and the way it's pre-trained. Perfect. So this works out of the box now. Score-based channels, test, ML. Commit, make test.ml runnable out of the box. We could expand the README section with all these. Okay, next one, ML works. Let me close some of these guys. We don't care about them. Test LDMP works, ML works, MMSC. CC spacing 05, 1664. There's no way this works. No, it should work. Oh no. Again, hard-coded paths. Wow. Okay, so we can also fix this because we can do pre-trained models, score, deepest, CDLC. Now for the other ones, it's up to users to train them. Yeah, this will not... Yeah, there's a deep MIMO here too, which is pretty wild. These have been hard-coded paths in public for so many years. But again, let's not clean them up yet. What I'm more curious about is... Do I have data loader here? I think I'm gonna have the same thread issue. Is there channels? Data loader, num workers 0. Okay, for good. So then UV run -m score based channels dot test MMSC. This should now load the model. GPU. Not 1, 0 by default, because some users don't have 2 GPUs. Very good. So that's another fix to make this runnable out of the box. Oh no, this one needs hyperparameters too. We should have uploaded these to pre-trained models too, right? Like the best hyperparameters we tuned. They're definitely in the paper somewhere. What the heck, where are we supposed to get these from now? Yeah. So are you supposed to run the tune? And this gives you our... I think so. You're supposed to run the tune and it gives you a hyperparameter file. Now the question is, does the tune work? Probably. Yeah, this one does work because it looks in model score. Okay, so the full thing is you're supposed to run train. We should have targeted the pre-trained model though, right? For people to see. We actually hurt ourselves because papers can't reproduce the tuning that easy. They have to edit code. Let's mock this then. Oh no, because how many, is there a number of steps or something here? What is the tuning? It's pretty complicated because we have to sample everything. Yeah, there's an alpha step range. This gives you the coarseness. We don't have enough compute to run this right now. So what do we need from the hyper file? Contents, best step IDX, best noise, and that's it, right? If we knew what these were, we could definitely, it's kind of better to hard code them. I actually know where those are. Let's leave it for now. We'll put it as a to-do. So fix MMSC. Now we did do a tiny teeny fix here. Yeah, we fixed some GPU and the pre-trained model, which is some progress. Okay, so we want these. Score-based channels, test MMSC. Partial fix to test.mmsc. Not fully though. which is fine. We'll leave this test score. This one should work for sure. Aha, and we have a model here, right? Score. Oh, I see. Let's just rename this magically. Whoops, not delete. Let's just rename this magically to final underscore model. So now it exists, and that should be it. UV run dash M. Score based underscore channels dot test dot score. This is very important. This has to work. Oh, see, we know. Oh, wait, look, these are. Oh, no, but MMAC has its. No, these are the best hyperparameters. Wait, alpha, best step, beta noise. Okay, this works. We found 2 of these. And what is the best stop? That we don't know. We have to look in the paper. No, it's better. I'll find these and I'll upload this file to GitHub, I think. Oh, because this is what IDX. Oh, I see. This is. Oh, it's a matrix. Okay, yeah. Okay, I need to find these. Yeah. Okay. So, score works. WGAN. We have a trained model. Let's see. And we fixed the test path. GPU 0, we want this because some people don't have 2 GPUs. Haha, I found it. Num workers, this will not work. It has to be exactly the same fix we did for training. It's 2 doesn't work on Windows for mysterious reasons that we're not gonna get into. But okay, this should be it for WGAN. So let's see, UV run dash M score based channels dot test dot WGAN. Oh, I see. It's looking for Epoch 6000. Okay, we'll magically name the model Epoch 6000 then, no problem, right? Because assuming users will run this for the full training duration. What is it's extra 1? No, this is wrong. We don't want this, right? Yeah. This is some leftover that doesn't work. Again, some. Okay, why not? Wait. Oh, we trained for CDLD? Oh, because I forgot to change the GAN to C? Who is CDLD here? Well, now I'm very confused. Why do we save again? Oh my god, it's actually hard-coded here. Okay, well, this is also obviously not going to work. So this has to be exactly what the test is, which is a string. Good, a string. Okay, and that string is the first here and the first here. Oh my god, we need to switch to F strings too. It's fine. It is config data channel. Yes. And here it's also config data channel. Okay. So now we're also going to magically rename this folder to as if it was CDL minus C. And now the test should find it for sure. Yeah, we definitely need to add a README section now because we're actually making these work for the first time ever, which is pretty hilarious. Now, test in line 66. And extra layers is an integer. Config extra gen layers. What is the config? Is it loaded? And there's no field called extra gen layers. So what does the train do? Is there an extra gen layers? Aha, it's an extra layers. Oh no, that's just so how do we do DC? Let's see, Control F, DC Gigant G hours. Okay, so it's just an extra layers, which is just config and extra layers. Right. Yeah, this is not gonna work. This is not supported. Or in any case, it doesn't work. So whatever the intent was here doesn't help anyone. So we might as well make it work. Okay. Okay. Well, I don't know what the 5,000 steps mean, but sure. It's probably number of... Oh, total steps, I see. So what the heck is the total steps? Oh, I remember, because this is gradient descent over latent codes. Okay, okay, everything's good, good. So we did significant changes, let's see, to actually finally enable wgan out of the box. Change GPU, yes, workers, to do extra layers, CDL, okay, good. So we want both of these. Test wgan. Train wgan. Commit -m. Oh, harmonize. Make test wgan work out of the box. Okay. And finally, we have one more, which is the SigPy. So let's do it this way then. Let's do it fancy. We're gonna check out. So what was that other branch called? And we'll just ask to merge. So from SigPy to depths, we just want to check out the uv.lock file, and then we just do uv lock. What did I do? Why? Oh, I'm sorry. Wait. I think I have to check out both of them. And the Pi Project Tomo. Okay, so now if I do UV sync. Okay, they're back. Okay, so yeah, I have to check out both of them. So SigPy is back now. I believe this script should just work then. UV run -m score _ base channels. Now this I don't know if this name is bad, but sure. We'll leave it like this. I believe this should work because this is not even GPU code. I doubt it doesn't load any models. It just saves it to results. Oh yeah, the only curious thing is I wonder if multi-threading works on Windows. If not, oh no, but it is a thread. Okay, it works, yeah. At least it runs. Now, whether we want to wait, I think if it makes it, okay, there's a bunch of stuff. Yeah, this is fine. Okay. So any changes? Nope, no changes. So we can restore Pi Project and UV lock. We can restore everything. We can sync again. So actually this is good because then merging the SigPy PR separately will implicitly fix this. Okay, well this is looking a lot better and I think I'm done here. Now comes the fun part. So We're on the submodules branch. Let's check out another branch, this time from this one. So we're gonna check out a format code. Rough format. This is gonna be wild. The changes here will be thousands of lines, but we already know nothing material. And what are we gonna do? Just run UVX rough format. I want to see something though. UVX rough format parameters. Sometimes I like the lines a bit wider. Rough format. All files and path to code and any subdirectories. Let me do a help here. So UVX rough format -- help. Okay, it's installing rough. Again, UV does everything by itself. So, line width. I think I saw it. Did I see it? Line length. There it is. This is the only one that I like to be non-standard. Other than that, rough is just a standard. Well, it's the code formatter you should use today. We'll talk about that some other time. But this is it. So UVX rough format. I forgot what it was. -- help. Line length. Line minus length. So UVX rough format -- line length. Let's give it a 110. 108. I like longer lines. That's it. 34 files reformatted. So the differences are everything was changed now. Like this is pretty wild, right? All the code. Oh my God, there's so many changes. Like no more indenting, so many, but it's all standard formatting. Like this is wild because this looks like Python to me now, finally. Yeah, all the imports are spaced, all the config. Look at this. Wow, this is such nice spacing. Finally, this is readable code. Wow, look how nice this is. It's a nice division. You can actually read the division now versus what it was before. What was it before? Oh yeah, it was like, this is wild. Like this sum was split in 3. This one, it's like barely you can see this divide here. Now you can clearly see that it's a division of 2 sums. Spacing. That's it. And this is guaranteed because obviously rough is a tool used by billions of people. I messed up. We don't want to reformat Yang Song's NCSN v2 repo, so we're actually going to do UVX rough format src. Okay, just our source code, and we're also going to want to reformat plot and tune hyperparameters score. Okay, so we're going to git add src star and git add plot and tune. Reformat using line length. Well, let's just paste the whole command, right? UVX rough format line length 108. Just so we have a log. Wow, thousands of changes. Push. Now remember, we branched off of the submodules branch, so we'll have to merge that PR first whenever we open the PRs. I can't believe how good this looks. All right, we can delete the results. We'll leave the data because we'll play around with it tomorrow. What else do we need to do? Oh, look how nice this looks. Complete log. Good. I think this is it for now. So we did a bunch of changes, and but UV makes formatting so easy now, right? All you have to do is just one line. Now the code is starting to look a lot better now already, right? We have I can't believe one of my folders is named TWC Rebuttal. And this has been in public all this time. That's so funny because we used to do it for the paper. There's so much info in this repo that's somewhat leaked, but it's not really. All right. I mean, this is the whole point of open source taken to the extreme. That's it. So I'll open the PR. So yeah, thanks for tuning in. Thanks for stopping by. And there's still more stuff to do, but we'll keep fixing this repo in some other sessions. All right, that's it.